Hello everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about question bank discussion. So, Module 2, that is probability distribution. So, here the content is question bank of probability distribution. In this, we have part A, part B, part C. Part A is short answer questions and part B is long answer questions and part C is based on problem solving and critical thinking questions. So in probability distribution, we have only three topics are there. First one is binomial distribution. Okay. Second one is Poisson distribution. And third one is normal distribution. So here we have only three topics in probability distributions in module 2. So coming to the part A, first question, 20% of times produced from a goods factory are defective if we choose 5 items randomly. So this is items. So okay. 20% of items produced from a goods factory are defective. If we choose 5 items randomly, then calculate the probability of non-defective item. So here, non-defective, we should focus on defective item. So here they have given that p-value, that is 20%, and n is 5. That is 20% means 20 by 100. Okay, so from that we can calculate q. Q is nothing but 1 minus p. So after that, here we have p value, n value, q value, and we need to calculate non-defective item. That means p of x equal to 0. Okay, so here the formula is p of x equal to x. We have to use the binomial distribution formula. P of x equal to ncx, p power x, q power n minus x. So this is our formula. So now coming to the next question, probability of no misprint. Probability of no misprint is e power 4. E power minus 4. Calculate the probability that a page of book contains exactly 2 misprints. So here we need to calculate p of x equal to 2. So here they have given that no misprint. For no misprint, p of x equal to 0, they have given that e power minus 4. But here I am using Poisson distribution formula, that is e power minus lambda power x by x factorial. That is p of x equal to x, that is equal to. Okay, so here they have given that p of x equal to 0. Here small x value is 0. That's why e power minus lambda power 0 by 0 factorial equal to e power minus 4. So from that we can calculate lambda equal to 4. So but here we need to calculate the probability that a page of book contains exactly 2 misprints. So we need to calculate for p of x equal to 2. Just you have to substitute e power minus 4 power 2 by 2 factorial. So now coming to the next question, assume that 50% of all engineering students are good in mathematics. Determine the probability that among 18 students are exactly 10 are good in mathematics. So we need to find for p of x equal to 10. So here 18 among here they have given that n equal to, this is p value. So we have to use same like first problem. We have to use the binomial distribution formula. So now otherwise we can use Poisson distribution also. For every binomial distribution problem we can find by using Poisson distribution also, because we have one condition, that is lambda equal to np. So now coming to the fourth question, if the probability of a defective bolt is 0.2, so p equal to, calculate mean standard deviation for the bolts in a total of 400. That means n equal to, they have given that 400. So we need to calculate mean. So mean of the, if I use binomial distribution, mean of the binomial distribution is np, and standard deviation of the binomial distribution is under root of npq. Okay, so from that we can calculate. Already we know that n value, p value. What is q? Q is nothing but 1 minus p. Okay, so now interpret the properties of binomial distribution. We have to write the properties of binomial distribution. So now coming to the next question, if n equal to 4, p equal to 0.5, then calculate standard deviation of the binomial distribution. So here they have given that we have to calculate standard deviation. Standard deviation of the binomial distribution is npq. Already they have given that n equal to 4 and p equal to 0.5. So what is q? Q is nothing but 1 minus p. So now explain the properties of Poisson distribution. So the properties are there in discussion is there in our theory classes. You have to go through that class or video. So we'll build the binomial distribution for which the mean is 4. So that means mean of the binomial distribution is NP equal to 4 and variance is NPQ equal to 3. So next, so if X is a normally distributed, NPQ. So from that we can calculate P value, Q value, P value, Q value and N value. Okay, so because the NP equal to 3 now, so here, NPQ equal to 3 and NP equal to 4. So from that we can find Q value, that is Q equal to 3 by 4. So if I substitute P equal to 1 minus Q and Q equal to 1 minus P, so that is 1 minus 3 by 4, that is 1 by 4. So if I substitute P value here, that is 1 by 4 equal to 4, N equal to 16. So what is the binomial distribution? Here binomial distribution is P plus Q whole power N. Okay, so that is 1 by 4, 1 by 4 plus 3 by 4, that is whole power 16. So that is always equal to 1. So now coming to the next question, if X is a normally distributed with the mean 2 and variance 0.1, then calculate probability of modulus of X minus 2 greater than 0.01. So mean is nothing but mu and standard variance is sigma square. From that we can calculate sigma. Okay, so but here we have to use Z equal to X minus mu by sigma formula. So here we have to take this is 2 minus 0.1. So that is 2 minus 0.01 is this is 9 and this is 1. So 1.19. So 1.19 less than Z less than. So this is 2.01. Okay, so like that we have to calculate. So probability of 1.19, 1.99, not 19. So this is 1.99. Probability of 1.99 less than or equal to Z less than or equal to 2.01. Okay, so here they have given that mu equal to 2 and sigma square equal to 0.1. We have to calculate sigma from variance, but the main formula is here Z equal to X minus mu by sigma. So now coming to the next question, if X is a Poisson variate such that P of X equal to 1, that is equal to 24, that is equal to P of X equal to 3. So here we have to use the Poisson distribution formula. So the Poisson distribution formula is P of X equal to X, that is equal to e power minus lambda power X by X factorial. So we have to use this formula. Okay, so here they have given that P of X equal to 1, that means small x equal to 1. Here the value is small x equal to 3. So e power minus lambda power 1 by 1 factorial equal to 24 into, so e power minus lambda power 3 by 3 factorial. Okay, so by using this one we can calculate lambda value. After that calculate mean. So mean of the Poisson distribution is lambda. Okay, so just you need to calculate lambda value. So next, explain the properties of normal distribution of the properties of normal distribution. So we have to the normal distribution properties and interpret the properties of binomial distribution and derive the recurrence relation for binomial distribution. So we have for the recurrence relation, first P of X equal to X, that is equal to NCX P power X Q power N minus X, and we need to calculate P of X. This is P of X and we need to calculate P of X plus 1, that is NCX plus 1, P power X plus 1 and Q power N minus X minus 1. Okay, X plus 1. Okay, so from that we can calculate P of X divided X plus 1 divided by P of X. Okay, so this is our recurrence relation. Next, mean and variance of the binomial distribution. Mean is NP and variance is NPQ. So from that we can calculate N value, P value, Q value. So after that we have to calculate P of X equal to 1. So because the binomial distribution formula P of X equal to X is NCX P power X Q power N minus X. So by using this formula we can calculate P of X equal to 1. Next question. In 8 throws of a die 5 or 6 is considered a success. Calculate the mean of success. So just we have to use binomial distribution formula. So if the bank received on the average of 6 bad checks per day, calculate probability that it will receive 4 bad checks on every day. So just we need to write P of, we need to find P of x equal to 4. So here they have given that lambda value. Just we have to go through the Poisson distribution formula. So the Poisson distribution formula is here P of x equal to e power minus lambda, lambda power x by x factorial. So now coming to the next question, illustrate the properties of normal curve. This is most important. I will tell you once again. So totally the normal distribution problems are depends on normal curve and only. The normal curve is bell shaped and it is symmetric about x equal to mu and z equal to 0. Left side values are negative values and right side values are positive values. The total probability of the normal curve is 1 and left side area is 0.5 and right side area is 0.5. The total area in the normal curve is unity. So that's why this total value is 1 and this is 0.5, this is 0.5. And the total probability in the normal curve is 100%, this is 50%, this is 50%. So most important thing is here the normal curve. Normal distribution problems totally depends on the normal curve. So next, state the formula for mean variance of the Poisson distribution. So mean of the Poisson distribution is lambda and variance of the normal distribution is also lambda. State the formulas for mode of the binomial distribution. So mode of the binomial distribution is mode equal to actually n plus 1 into p if it is an integer. If it is an integer. So the integral part of n plus 1 into p if it is not an integer. Integral part of n plus 1 into p if it is not an integer. So coming to the next question, state the formulas for mean and variance of the binomial distribution. Mean of the binomial distribution is NP and variance of the binomial distribution is NPQ. So now explain the properties of Poisson distribution and derive the recurrence relation. So this is also same. So here P of x equal to e power minus lambda, lambda power x by x factorial. We need to write P of x plus 1 e power minus lambda, lambda power x plus 1 divided by x plus 1 factorial. So just we need to calculate P of x plus 1 divided by P of x. Okay, so this is our recurrence relation of the Poisson distribution. Now coming to the part B. So our first question is, out of 20 tape recorders, 5 are defective. Calculate the standard deviation of defective in the sample of 10 randomly chosen tape recorders. Calculate, first one is P of x equal to 0 and second one is P of x equal to 1 and third one is P of x equal to 2 and fourth one is probability of 0 less than x less than 4. So here they have given that 5 out of 20. That means they have given that P equal to 5 by 20. Okay, so that is 1 by 4. So P is 1 by 4. We know that Q is nothing but 1 minus P, that is 1 minus 1 by 4, that is 3 by 4. And what is N value? Here N value is 10. Okay, so and calculate standard deviation of the, here I am using the binomial distribution formula. So that is P of x equal to x, that is equal to NCX, P power x, Q power N minus x. Okay, so and the standard deviation of the binomial distribution is under root of NPQ. And here the last one is probability of 0 less than x less than 4 is nothing but, so in between values we have to take, because here we are not having equal to symbol, so that's why, so we have to take P of x equal to 1 plus P of x equal to 2 plus P of x equal to 3. Okay, so that is our first question. So remaining formulas, remaining questions we have to use this formula, P of x equal to x, that is equal to NCX, P power x, Q power N minus x, because here small x value is 0, here small x value is 1 and here small x value is 2. So coming to the next question, a car hired from a car hired from has 2 cars which is hires out day by day. The number of demands for a car on each day is distributed as a Poisson distribution with mean 1.5. So that means they have given that lambda value. Calculate the proportion of days, first one on which there is no demand. So that means P of x equal to, here we have to take 0 and our demand is refused. So here we have only possibility is there for 2 cars. That means here we need to calculate P of x greater than 2. Then only the demand will be refused. So that's why P of x greater than 2 means 1 minus P of x less than or equal to 2. So that is nothing but 1 minus P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. So here they have given that lambda value. No, we have to use the Poisson distribution formula, that is P of x equal to x. Poisson formula here I am using, that is e power minus lambda power x by x factorial, because here they have given that lambda value. Now coming to the third question, the average number of phone calls per minute coming into a switchboard between 2 p.m. to 4 p.m. is 2.5. So average is nothing but mean is nothing but lambda here. Lambda value they have given that that is 2.5. Estimate the probability that during one particular minute, 4 or fewer calls, that means P of x less than or equal to 4 here. So here more than 6 calls, P of x greater than 6. Okay, so here they have given that lambda value, lambda is 2.5 here. Okay, so we need to find first one P of x less than or equal to 4. So that means, so that is P of x equal to 0, 1, 2, 3 and 4. So this is our first question. The formula is here P of x equal to x. Poisson distribution formula here I am using P of x equal to x. So that is equal to e power minus lambda power x by x factorial. Okay. So this is our first question. And coming to the second question. So we need to calculate second one. Second one is we need to calculate P of x greater than 6. X greater than 6 means 1 minus P of x less than or equal to 6. Okay. So that is 1 minus P of 0, here P of 1 plus P of 2, or P of x equal to 2, or P of x equal to 3, P of x equal to 4 plus P of x equal to 5. We have to take P of x equal to up to 6. Okay. So that is our third question. So coming to the fourth question, 10 sets of trials per an event of small probability of frequencies of f of the number of x of success are calculate the expected frequencies of using Poisson distribution. Here we have to fit the Poisson distribution. Here they have given that f values and x values, and here we need to calculate summation fx by summation f. From that we can calculate lambda value. So we have to use same Poisson distribution formula, but here we need to find the expected frequencies. Expected frequency for Poisson distribution. So that is P of x equal to, that is n into P of x equal to x. So that means n into e power minus lambda power x by x factorial. Okay. Now coming to the fifth question, for a normally distributed variate with mean 1 and standard deviation is 3. So probability of 3.43, so less than or equal to x less than or equal to 6.13. And here minus 1 less than or minus 1 probability of minus 1.43 less than or equal to x less than or equal to 6.19. Okay, so here let us consider which will be in the form of x1 less than or equal to x less than or equal to x2. So here we have to take z1 equal to x1 minus mu by sigma and z2 equal to x2 minus mu by sigma. So from that we can calculate P of which will be converted to z1 less than or equal to z less than or equal to z2. Okay, so we have to take z1, z2 values here. If we have negative values, then we have z is symmetric about the normal curve is symmetric about z equal to 0 now. So we have to take z value in the middle. If we have any negative value, we have to take in the left side, and if we have any positive value, we have to take in the right side. Okay, so this we need to find the in between area. So here to here area, here to here area, we have to use the normal distribution tables or normal tables. Same procedure. So now coming to the 16th question, if x is a normal variate with mean 30 and standard deviation is 5. So mu equal to, here they have given that 30 and standard deviation sigma equal to 5. Calculate the properties that p of x1 less than or equal to x less than or equal to x2 and p of x greater than or equal to x1. Okay. So here z1 equal to x1 minus mu by sigma, z2 equal to x2 minus mu by sigma. So we have to use this formula. So now coming to the next question, 4 coins are tossed 160 times. Here small n equal to 4 and capital N equal to 160, p equal to 1 by 2 and q equal to 1 by 2. Fit a binomial distribution getting the number of heads. So here fitting of the binomial distribution is nothing but expected frequency for binomial distribution. The expected frequency for binomial distribution is n into p of x equal to x, that is equal to n into ncx p power x q power n minus x. We have to use this formula to find the expected frequencies. Now coming to the next question, the mean height of 500 male students at a certain college is 75 kgs and the standard deviation is 7 kgs. That means mu equal to 75 and sigma equal to 7. So this is total value. I will explain you later. So assuming the weights of the normally distributed, calculate how many students weight in between. That means probability of 60 less than or equal to x less than or equal to 78. So more than 92. That means p of x greater than 92. Okay. So this is also same. Here also same. We have to use these two formulas. So after completion of the answer, we have to multiply with 500. So we have to multiply with 500. That means probability of Z1. So multiply 500 with this one. Z1 less than or equal to Z less than or equal to Z2. Okay. So after completion of the answer, we can calculate or we have to multiply with 500. We are finding for 500 male students. So now coming to the 9th question, the mean standard deviation of the box obtained by 1000 students. So after completion of the problem, we have to multiply with 1000 students like 8th problem. Okay. So here mu equal to 34.5 and sigma equal to 16.5. So here also same, we need to calculate 30 less than or equal to x less than or equal to 60. So this will be in the form of x1 less than or equal to x less than or equal to x2. So after that, we need to calculate z1 less than or equal to z less than or equal to z2, where z1 equal to x1 minus mu by sigma and z2 equal to x2 minus mu by sigma. So after completion of this, we have to multiply with 1000. So coming to the 10th question, if the masses of 300 students are normally distributed with mean 68, mu equal to 68 and sigma equal to 3, and we have to find greater than 72, no, p of x greater than 72. So this is less than or equal to 64, in between p of 65 less than x less than 71. Same procedure like the 9th question. So next, out of 800 families with 5 children each, calculate how many would you expect to have. First one, 3 boys. That means here we have to calculate for boys. So p of x equal to 3. So this is 5 girls now. We have to find for p of x equal to 0. So either boy or girl, p of x equal to 2 or p of x equal to 3. And assume equal probabilities for boys and girls. Okay, so now after completion of this, here I am using the binomial distribution formula. The binomial distribution formula is p of x equal to x, that is equal to ncx p power x q power n minus x. Okay, so after completion of the problem, we have to multiply with 800 for every question. Now coming to the next question, a Poisson distribution is such that p of 1 equal to 3 by 2 into p of x equal to, p of x equal to 1. So the Poisson distribution formula is, so here the Poisson distribution formula is p of x equal to x. Poisson distribution formula is e power minus lambda power x by x factorial. But here they have given that p of x equal to 1. So that means here small x equal to 1 and here also small x equal to 3. So that means I am calculating this one. So that is nothing but e power minus lambda, lambda power 1 by 1 factorial equal to 3 by 2 into e power minus lambda, lambda power 3 by 3 factorial. From this we can calculate lambda value. After that, p of x greater than or equal to 1, that is nothing but 1 minus p of x less than 1. Less than 1. So, wait. So, our first question is p of x greater than or equal to 1. So, that is nothing but 1 minus p of x less than 1. So, that is 1 minus p of x equal to 0. So, for the second question, we need to calculate p of x equal to 0 plus 1 plus 2 plus 3. Okay. So, coming to the next question, we need to calculate p of x, p of 2 plus p of 3 plus p of 4 and also p of 5 because equal to symbol is there. That's why we have to include 2 and 5. So, coming to the 13th question, the average number of accidents on any day on a national highway is lambda value. Here they have given that calculate the probability that the number of accidents at least and at most 1. So, we have to calculate at least is nothing but greater than or equal to 1, at most is nothing but less than or equal to 1. So, now coming to the next question, here they have given that probability of x less than 35 equal to 7% and the probability of x less than 63 equal to 89%. Okay, so from that we have to use by using the normal distribution, normal curve, we can calculate the value. So, the formula is here z equal to x minus mu by sigma. So, coming to the 15th question, a shipment of 20 tape recorders contains 5 defectives. Calculate the standard deviation of the probability distribution of the number of defectives in a sample of 10 randomly chosen for inspection. So, here p equal to 5 by 20 and q is nothing but 1 minus p and here n equal to 10. So, here I am using the binomial distribution formula. So, that is p of x equal to x, that is equal to ncx p power x q power n minus x. Now, coming to the 16th question, 1000 students have written an examination with mean. Here mu equal to 35 and sigma equal to 5 and we need to calculate first one. So, first one is probability of 25 less than x less than 40 and we can write less than or equal to also. So, more than x more than 40. So, next third case is here p of x less than 20. So, here we have to use x minus mu by sigma formula. So, now coming to the next question, fitting the binomial distribution, here they have given xf. So, here mean equal to summation fx by summation f. So, from that we can calculate mean is nothing but np. Here n value is 5. So, from that we can calculate p value, q is nothing but 1 minus p. So, the expected frequency, fitting of the binomial distribution or the expected frequency of the binomial distribution is n into p of x equal to x. So, that means we have to use n into p of x equal to x means ncx p power x q power n minus x. And the next question is, this is recurrence relation. So, here we have to find p of x, that is e power minus lambda, lambda power x by x factorial. We have to calculate x minus 1 also. So, that is e power minus lambda, lambda power x minus 1 by x minus 1 factorial. Okay, we need to calculate p of x divided by p of x minus 1. So, that is our recurrence relation. Now, coming to the 19th question, the life of electric bulbs, certain type may be assumed to be normally distributed. So, here they have given that mu and standard deviation sigma and here also same, we need to calculate first case. First case is probability of 136 less than x less than or equal to 174 and second case is probability of x less than 117 or less than or equal to 117 and third case is we need to calculate p of x greater than 194. Fine. So, the formula is here x minus mu by z equal to x minus mu by sigma and the last question is hitting a target is the probability that a man hitting a target is 1 by 3, that means p equal to 1 by 3, n equal to 5 and q equal to 1 minus p. So, what is the formula? The binomial distribution formula is p of x equal to x, that is equal to ncx p power x q power n minus x. So our first question is we need to calculate at most. At most is nothing but less than or equal to 3. At most 3 times. P of x less than or equal to 3. So this is our first question, and second question is at least P of x greater than or equal to 2. Next, show that this is the derivation. Show that the Poisson distribution is a limiting case of binomial distribution. We have to take the binomial distribution. We have to prove that Poisson distribution by using the 3 conditions of the Poisson distribution. So next, explain the properties of normal distribution and calculate the variance of the Poisson distribution. This is also a derivation. And explain the properties of normal distribution and determine the mode of the normal distribution. So this is also a derivation. And explain the properties of normal distribution and calculate the median of the normal distribution. So these are all derivations. And the next question is the marks obtained by statistics in a certain examination found to be normally distributed. So here 15% of the students greater than or equal to 60. So that means x greater than or equal to 60. X greater than or equal to 60 equal to 15%, and x less than 30 equal to 40%. Okay. So x greater than or equal to P of x greater than or equal to 60 equal to 15%, and x less than 30 equal to 40%. So here we have to use x minus mu by sigma formula. So Z1, Z2 we have to take. So coming to the next one, the variance and mean of the binomial variable x with parameters. So variance is NPQ, and mean is NP. So here we have to use the binomial distribution formula. So that is P of x equal to x, that is equal to NCX P power x Q power n minus x. Okay. So here we need to calculate n value, p value, and q value also. And coming to the next question, the expected frequency of binomial distribution is that is n into P of x equal to x. So the formula is, the binomial distribution formula is NCX P power x Q power n minus x. So like that we can calculate the expected frequencies. And this is also a derivation. 8th question is also a derivation, the mean of the normal distribution. And the 9th question is 7% of the students score less than 35. So P of x less than 35 equal to 7%, and P of x greater than 63 equal to 11%. Okay. So this is also a normal distribution formula. So in that we can calculate mu and sigma. But here the formula is x minus mu by sigma. Z equal to x minus mu by sigma. And last question is explain the properties of binomial distribution and obtain the formula for mean of the binomial distribution. The mean of the binomial distribution is NP. We have to derive for NP. So this is also a derivation. So this is our module 2 probability distribution question bank discussion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.